Okay, today we are going to talk about increased limit factor. This is just a continuation of what we discussed last class, which is about policy limit. Okay, to understand this concept, the increased limit factor, or ILF, measures how much more the insurer expects to pay by increasing the policy limit. It can be calculated as follows. ILF is equal expected value of x capital mu over expected value of x capital B, where B is the original limit and mu is the increased limit. Let's look at this example to further understand the concept. Claim size for a medical insurance policy follows a Pareto distribution with parameter alpha equal 5 and theta equal 1000. The insurance company considers raising that policy limit from 500 to 800, determine the increased limit factor for a claim. So first, we need to know that this is just the application of a formula on the right side, which is already given in any of the spreadsheets or the formula sheets. So all you need to do is apply the function, apply the numbers to this formula. So let x represent the claim size. X follow the Pareto distribution 5, alpha equal 5 and theta equal 1000. The Pareto distribution limited expected value is given in the exam table. Look at the value and we can calculate the expected value for x capital 500 is this. And if it's capital 800 is this. So the factor is 1.1274, which just tells us that if the policy limit raised from 500 to 800, the expected limit factor is only increased by 12.74%. Okay, later we are going to talk about the similar concept when the situation is empirical distribution. But in order to talk about that, we need to understand some of the concepts, ALAE and ULAE. So in addition to losses, expenses need to be accounted for in the rate-making process. There are two main categories of expense to consider: loss adjustment expense and other expenses. Loss adjustment expense (EL), also known as LAE, are costs that are incurred during the claim settlement process. They are typically accounted for as part of incurred losses. Loss adjustment expense can be further separated into allocated loss adjustment expenses and unallocated loss adjustment expense. So it's ALAE and ULAE. One is allocated, one is unallocated. Why there are such differences? Because this is the nature of the expense. ALAE are expenses that are associated with a particular claim. For example, lawyer's fee, it can be specifically assigned to each claims. And there are also unallocated fees. For example, salary of the claims department manager. Because the manager is in charge of the whole department, you cannot separate the expense between this claim and that claim. That's why it's ULAE. ULAE are expenses that are not associated with a particular claim. It's not associated with a claim. Just like the salary of the department manager, you cannot be associated with a specific claim. Okay, now let's back to the concept that we were talking about, increased limit factor. Earlier we talked about a continuous increased limit factor. Now let's talk about this increased limit factor in the context of empirical distribution. So let Xi represent the ith loss for a policy that has a policy limit mu. the insurer's expected payout per loss is called the limited average severity. Limited average severity mu is just by summing up all the payments of this loss and divided by number of loss, which is m. And the payment of loss for the payment of loss, you can compare it to mu. So if it's less than mu, then the payment will just be the loss xi. If loss is greater than mu, then the payment will just be mu. So that's the second formula is trying to say if x is less than mu, you add xi, but if it's greater than mu, you use mu as the payment. Then by the definition of increased limit factor, the indicated severity or the limit factor is L, loss limit average severity mu over limit average severity b. This is called the increased limit factor. Okay, this slide just further explain the difference between the theoretical world and the empirical world. So the first formula, expected value of x capital mu, is using the integral of the x times fx from 0 to mu plus mu times s mu. If it is continuous, if it's discrete, you use the sum of the x times px. But in the empirical world, we just use expected xi time divided by m is the total number of empirical results plus mu times m mu over m. M mu just means the number of claims that is greater than mu. Now let's look at this example. For a policy with a limit of 500, observe the following claims. 400, first claim 400 with ALAE 200, second 300 with ALAE 100, third claim 600 with ALAE 300. So the question is calculate the average payment per claim if the policy limit include ALAE. So for the policy with a limit of 500, let's look at this. First claim loss 400 plus ALAE 200 because it's first question is asked include ALAE, so this first is 600. 600 then limit is 500. So in this case, it's more than limit. 600 is more than limit, so it will be payment will be 500 in the first case. The second one 300 plus 100, limit is 500, so 400 is less than 500, so it will be 400. Then the third one is 600 plus 300, 900, limit is 5, so it will be 500. So in this case, we are just adding all three together divided by 3. That would be 500 plus 400 plus 500 divided by 3 is equal. So the first question is 500 plus 400 plus 500 divided by 3 is equal 467. This is the average payment per claim. Now, the second question is asked if the policy limit does not include ALAE. In this case, the payment will be different. So the 500 limit, 400 loss, so it's 400 plus 200. equals 600. So it's saying that when we compare loss to limit, we only use loss to compare limit. So in this case, 400 compared to 500 is 400 is less than 500, so we put 400 there, but we always need to add the ALAE no matter what. Then the second one is 300, which is less than 500, so it's there, plus 100 ALAE, so this is 400. The third one is 600, but the limit is 500, so you 500 plus 300, which is equal 800. So in the second case is 600 plus 400 plus 800 divided by 3, which gives you 600. So this is the difference between includes ALAE, not include ALAE. So if it doesn't include ALAE in the comparison of loss to the limit, you still need to include it in the final calculation of payment, because essentially this is the expense that the insurance incurred, so it should be included. Okay. So this example gives you a little more understanding on how you utilize the information ALAE. Now let's look at the second example. Sigma Insurance Company issues auto policies at a basic limit of 5,000. You are given the following claims experience. The policy limit includes ALAE, and the loss. Therefore, the given loss is also include ALAE. So basically, you just need to compare the loss to this total of loss plus ALAE. And the question is determine the IRF for policy limit of 10,000 and 50,000. Okay, so for the policy limit of 10,000, first we look at the loss size. If we do 0 to 5,000, then it means it will be the loss will be the same as the payment. So the total for the first category will be 966,000, so 9.66 million. And for the second category, where the loss is 5,000 to 10,000, it will still be less than 10,000. So let me write it here. For the 10K and the 50K, two different cases. So this one would still be the same. I'll just use this. But when it gets to the third category, 10,000 to 50,000, or even the fourth category, 50,000 to 250,000, in this case the 10K is less than the loss size, so limit is smaller, than limit will be used. So in these two cases, 10K will be used for both three or fourth case. So 1, 2, 3, 4. 10K will be used. But if the limit is 50K, similarly we will use first one, we will use second one. But for the third one, we still will use the actual number there, and only the fourth one will use 10K. We'll use 50K because this is capped at 50K. So in the first case, LAS when it's 10K is, I'm going to just write it in thousands to avoid all the zeros. So 1, 2, 3. First two category will be used. Then starting from third category, you just use the actual claim number times the 10K divided by 8. Because there are 8,000 losses, and this will give you 4573 times 75, and the second one is 50k. This will still be 9660 plus 12300 plus 251010 plus 50k times 46 divided by 8. So this will give you 6158.75. Then you can calculate the ILF 10K to be 4573 times 75 divided by, you also need to calculate base, which is, you can use similar way to calculate it. It's this 1 pole and ILF. Similarly, ILF 50K is calculated. So then you will, this is how you calculate both. The next concept that I'm going to talk about the risk load. From the fundamental insurance equation, premium should be equal to loss plus expense plus profit, because whatever the policyholders provide its premium, should be able to cover both loss, the expense, and profit. We know that it's essential to include provision for expenses and profit when setting premium rates. When pricing a higher limit policy, some companies will include an additional provision to account for the risk of the increased limit. That is, the uncertainty of having increased over covered loss. This additional provision is called the risk load, RL. To include the risk load, we can modify the formula to be IFLU equal LASU plus RLU over LASB plus RLB. The determination of the risk load is beyond the scope of this exam. If an exam question intends for a risk load to be included, it would specify the risk function. Now let's look at this example. This example is actually exactly the same as the last example, except this example includes the concept of risk load. Okay, it says assume the risk load function is the limited average severity squared divided by the total number of losses. So RLU Earlier we already calculate LAS basic limit is 3206.62 and LAS 10K is 4573 times 75 and LAS 50K is 6158.75. Now RLU is calculated as LASU square divided by M. So really, determine the inflation risk factor, inflation limiting factor. We just calculate all three using the formula. Now, first we need to calculate the RLU. using this function. Then later we just calculate so first stage calculate RLU for each, and second stage apply the function, apply the formula. In this type ILU is whatever that original, you have to add the RLU here. Okay, I will provide the answer to this, but I cannot write it anymore here.